Right, let's continue to finish this for loop, how we should make the copy from a linked list. Right, so when you have the original stack, so we're using the p equal to the first node, then we just iterate next one is p equal to the p next. So when p reach the end, so p will equal to 0, so we finish. So when we create that, right, so after we have the p, right, so this p always start from the first node. Then we need to copy over one by one. So according to this p, I will create a temp node. So this temp node value will the same as the p value. Okay, and also one thing is p next we will copy later. So actually the temp next will just be 0. We just want to using this one to have the new value we copy. But here you see our code is a little weird. We have a last node. So then if the last node not equal to 0, last node next equal to the temp. Else, first node equal to temp. Then last node equal to the temp. So what's this last node came from? Okay, so this last node is actually we need to be careful when we do the copy. So that's why I need to show you in graphically how this copy came from. So you see this one is earlier we said, right? That's our original linked list. You will have first node, so then next. Okay, so when we have the p, we're just using the p to make the copy. Right, but now you need to think about this is original linked list. So now here is our copied linked list. Right, so when we start make the copy p, right, so I make the temp here. So this temp need to have the same value as the p value. So the temp value equal to the p value. Then, because I don't have the next node yet, so that's why this temp node next equal to the no pointer, okay, no value. So now we need to be careful. You see, when we add the node before we add to here, so every time when we add a new node, we add to the beginning. But now when we do the copy, right, we do one by one. So actually we start copy the first node, then we do the one by one. So that's why you will see here, after we have the first node, we finish the p copy. This node should have their first node point to this value. But after this first node point to this node, right, can I using this first node to travel again? No, because when you copy this one, right, their first node need to be equal to my first node. Before, when we do the push, we're using the first node to travel. But now, because we're using the copy, when I copy, I only can copy stuff from the first node. But after I copy the first node equal to this first node, right, I never move anymore. So now, but you see here, p need to continue to move. On the other hand, when I copy, I also need to have a pointer to help me to move. So this one is the last node. So that's why here we have a last node. This last node helps us to move to the next. But this last node, when we have the first node copied, right, they will only point to the only node here. So that's why you will see here. When the last node equal to 0, that means I have really the first object I want to copy. So then we make the last node next equal to the temp. Okay, so then, okay, sorry, if I have last node, actually when I have last node equal to 0, right, my last node actually not changed yet. Okay, my last node actually is always equal to the new temp. So if the last node equal to 0, that's false, right? So then you see first node equal to the temp. Then after we finish, the last node always point to the temp node we want to add. I know it's still a little confused. Let me show you the second node, you will see. So you see after we copy this one, right, you agree they should look like this, right? Because your first node should point to this object. Last node should be this one too. And this node next equal to the node pointer. Good, so continue. So P finish, P go next. So when P go next, P come here. Then I need to create another temp, right? So now after I have P, right, so P go next. I create another temp. So this temp value equal to this P. So the temp next equal to the node. So like earlier we say, okay, first node cannot move. Only my last node can move. So that's why here, the same thing. So after we have that, right? So then you see if the last node is not equal to 0, great. The last node not equal to 0. I need to make my last node will equal to the last node was here. The last node was here. So I need to have this last node to move to the point to the next object. So that's why you see here, the last node next equal to the temp. Yeah, so you see here. The last node, okay, you see the last node next. So that's why here the last node next is this one because I need to make the connection. So the last node next equal to this temp. Then the last node equal to the temp if I have the last node. So did you see that? Actually here we need to using this last node to help us to move. So again, we finish this one, the second node copy. So again, P go next. So that's why you will see the P moving. And again, every time when I have a new node, I'm using the last node to move. The last node always equal to the last node next point to the new temp. Then the last node point to the temp. So afterward, we finish the copy. Okay, so you need to be careful for the linked list copy is very abstract. You really need to make the graph like this so you know what we are doing. Even I try to explain to you like this, you need to also see the code and match with how the visually look like to make sure you understand. So that's why here you will see our copy constructor. So this copy constructor implementation, that will be here, okay? So the copy constructor implementation, right, we need to have a for loop is for the original array. So original array start from first node. So then we go each iteration P to the P next. So every time when you create a new temp, you're using the P value. Okay. Then here actually they can, yeah, because the P next, the node next actually not important. But for us, we always make this one is 0. Okay. You want to do a P next, it doesn't matter. So either way is fine. Or we just do 0 because anyway later we will update. Okay, so then after you have this node, right? Right. So if you have last node, okay, so then we're always using the last node to move. So last node next equal to the temp. Otherwise, the first node need to give them the allocation. So no matter which case, the last node assigned to temp. So that's how to copy. But before you copy, right, we need to copy over the size is equal to the original size. And the first node, of course, we start from 0. So here we'll update. And remember, we need to create a local variable called last node. So the purpose for this last node actually just help us to, in the for loop, to make the copy. So that's the copy constructor. So after you finish the copy constructor, how about your assignment operator? Right, did you remember assignment operator? Assignment operator means you originally already have a stack. You already have your linked list. So that's why when you do your assignment operator, they will be very similar. So actually that copy part will be similar as the copy constructor. But when you do the assignment operator, make sure the first thing we need to check, are they the self-copy? If not, we need to call, you can either call clear, or you see here is our while loop. You need to deallocate existing list. So that's why actually what you do, you can either call clear, or you see while we have the first node, we just remove the first node, and we delete the node one by one. So after you delete the node one by one, so then you need to recreate your queue. So then you see here we have the last node equal to 0. We're using the P to travel through the original linked list. So then we create a new temp. So then the value is the value or 0. Pointer is 0. Then if you have the last node, so the last node next equal to temp. Otherwise, we assign the first node. So then the last node equal to the temp. So after you're done, your size equal to the original size. You can either do beginning at the end, doesn't matter. Also here, just do like this. So then you return this. So that's our assignment operator. So like we say, your assignment operator, you can do like this. Okay, you need to do the self-check, self-copy check. So then you see, you can either like to implement again, or we can just code clear. So then we build up the new linked list. So then we finish the linked list implementation. Yeah, so after you finish the linked list implementation, actually that's all up to you. Your assignment 7, lab exercise 7, I already told you, you can either use the array implementation, since we already finished in the first lecture. Otherwise, if you want to move ahead, you can do the lab exercise already for the array linked list implementation. So now, of course, now after the second meeting, we finished the linked list implementation. So for your assignment 7, either way is fine. I know maybe linked list for you now is too much. But one thing is, for this week, you have the choice. You want to use array list, you want to use array, or use a linked list. If you are not familiar with linked list so much, right? So you're just using this lecture to refresh your memory. But next week, when we do the queue implementation, you have to use the linked list. So I just want to let you know, this week you can choose either one. But next week, you have to use the linked list. So that's why I will recommend you, if you're not so familiar with linked list, so then you can using this week lecture as a review and refresh for you. Yeah, so then, yeah, we finished the implementation for our header file. So the next one, I just want to remind you about your test driver for your Part 1 in assignment 7. So here is your complete test. You know you always need to test all the public functions to make sure they work. So that's why you see your push, pop, pick, size, empty, clear, they all need to do that. They all need to be tested. So then you have constant object testing. So you need to test all the getter function. So here I'm using the underline for the getter, because you see pick is getter, size is getter, empty is getter. So you need to make sure the getter function work with the constant object testing. Then, right, we have copy constructor. We have assignment operator testing. So you need to make sure. So when you check the same thing, you need to make sure you will do the each for the first node. Yeah, actually, when you do the check, actually you can check the first node. So then on list, you need to pop every one. Then you can make sure every object they are the same. Okay, so that's why your copy constructor and assignment operator testing, you need to see, you need to make a copy first. So that's why otherwise when you do a for loop to pop every object, then your original stack will be gone. So then you need to make a copy first, then you will do the testing. And also, of course, you need to have the if not defined testing. So about the capacity setter function, because that's a private, you suppose the user cannot really code the capacity setter. So that's why no need to test that. It's a private function, because anyway, they will be tested in the push function. So you need to make sure when you push the object, you need to push the number more than your default capacity. So that's why we can make sure the capacity setter function being invoked correctly and being tested. And also you need to test on 2 different data types. String is required.